If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on advanced level where we are solving previous year IT JEE questions. So today we will be solving again 4 questions. Question number 5b, 6a, 6b and then 7. Okay, then let's try to solve these questions. So if you come to question number 5b, tangents TP and TQ are drawn from the point T to a circle this x square plus y square is equal to a square. If the point T lies on the line Px plus Q, some line is given, it is lying on that line. Find the locus of the center of circumference, locus of the center of the circumcircle of the triangle TPQ. Okay. So now this case I have already explained you while discussing theory. So let me from an external point, suppose these are the points. So I will name it in this way. So that is T and then it is P and then it is Q. So I told you this is a side because these angles are 90 degree. So if you draw a circumcircle of this one, it will be the center here. So for this also the center here, radius is this. So this circumcircle will pass through it. So these are 4 points O, P, T, Q, or it is C I have mentioned here. It is as I have written here as C. So all these points C, P, T, Q, they are cyclic quadrilateral. This quadrilateral because all the quadrilateral 4 parts lying on the circle. So it is the circumcircle for the triangle. So this is cyclic quadrilateral. So you will because you will find this circle is circumscribing CPTQ rectangle. It is also circumscribing CPT triangle. For this triangle also it is circumcircle. For which triangle? Another triangle CQT also it is circumscribing this triangle. For if you draw this triangle also it is circumcircle for PQT also. So for all this it is circumcircle for CPQ also. For all these triangles this is circumcircle because it is touching all these 3 points. So you can see this circle is very important. It is circumscribing lots of things. First it is circumscribing this rectangle, this quadrilateral, then this triangle, then this triangle, this triangle, this triangle. For any triangle if they ask you circumcircle, obviously this one will be there. And you know this one is the half of this one. Okay. So if it is, so what I need to find? The locus of which point? Circumcircle. So locus means this point's locus I need to find. So this is HK I will consider. If this is HK, then this is the midpoint of this one. So you can find this point. What will be? Because this is 0, 0. So it will be 2H, 2K. Then this will be the midpoint. 2H by 2H, 2K by 2, 2. So you know now you know the coordinate of this one. 2H, 2K. So if this, because this exists, this satisfies, this T lies on this line. So if you put it there, it should satisfy because you need to find a condition of HK. That is the idea of locus. So if you put 2H, 2K in the equation, it should satisfy. If you put it here, it should satisfy. So the equation that you got in terms of HK, that is the locus. Finally, you can put in terms of H, X and Y to write it in XY format, or you can keep it in HK format also. So this is the locus. And for cyclic quadrilateral, you know properties, sum of opposite angle is 180. So you can see sum of opposite angle, this plus this is 180, obviously then this plus this will be 180. So for that is also, because it is cyclic quadrilateral, sum of opposite angle is also 180, from that also you can prove. Okay, if you come to 6a, the tangent at the point P, tangent at a point P on the circle this one, meets the straight line this one at a point Q on the y-axis. So you have a straight line this one. So something of this type format. Why it is in third quadrant? Because the center if you see x square plus y square plus 6x plus 6y minus 2 equal to 0. So center is here minus 3 minus 3. So somewhere here suppose this is the circle. So a line is here. So they are asking you, this is the line 5x minus 2y plus 6. So they ask you the tangent at the point P on the circle this meets the straight line this at point Q. So this straight line Q on the y-axis. So this is the point on y-axis is where it meets. So another line from here, if you draw a tangent, it should pass through this point. So this is the point P. So from point P a tangent is drawn which meets the line at y-axis. So at this point it meets. Okay. So if, what is the point? You can find it because here it is meeting y-axis. That means x is equal to 0 here. So you put it here, you will find where this line meets with y-axis. You put x equal to 0, you find this point. So if you put x equal to 0, you will find this point is 0, 3. You put it 0, so y is equal to 3. So this point you know. So now you know this point, they are asking you length of PQ. So what is the length of PQ? That means they are asking length of tangent. What is the formula of length of tangent? Root S1, power of the point. For t equal to S1, length of tangent, the formula. So length of tangent will be root s1. S1 is you put the point on the circle. So you put the point that is 0, 3 on the circle, take under root, that is the length of the tangent. Now if you come to question number 6b, if a is greater than 2b, then the positive value is m, for which this is a common tangent to this. This should be common tangent to both this. Okay. So for this circle, you know a formula. What is the formula for common tangent? Is for a straight line to be tangent to this one, it should be that straight line y equal to mx plus c. C should be equal to, or c square should be equal to a square. A is here b square 1 plus m square. Or c should be equal to plus minus b under root 1 plus m square. This was the formula I told you for this. So obviously this is on this format. You can see y equal to mx. If you take the minus 1 minus b under root 1 plus m square. So this is obviously a tangent to this. Now you have to prove that this is also tangent to that. That's it. So you can take the from the center, because it is not centered this one. So you can take distance from this one a comma 0, and that should be equal to b, because it is also radius b. If it satisfies, then it should satisfy, then you will find the value of m. So you can do it in this way, because this line it is already tangent to this one. This is proved from the standard theorem also. Now what you will do, what is the center of second circle is this one, a0. From a0 you find the perpendicular distance of this line, y equal to mx plus b. You find the perpendicular distance from this point to this line, that should be equal to b. So you can put it there, a is equal to a, y equal to 0, so minus ma plus b into under root 1 plus m square divided by under root 1 plus m square, this square plus this square, that should be equal to p. So you can do it in this way, you will find the value of m. Or I told you that this is for the circle x square plus y square equal to a square, the condition is y equal to mx plus c. So this line has to be this one if c square equal to a square 1 plus m square. This was the condition. Now suppose the circle is of this fashion, y minus k whole square equal to a square. Then what should be this one? Then this line should be equal to of this format. Y minus k should be equal to, in place of y you have to put y minus k. Then this should be the straight line. C is already that condition. You maintain the condition of C, that you stick to this formula, but you replace x and y. So this straight line will be, because here if you simplify, that k will go that side, that mh also, C will change it little bit, a final constant, but you stick to this formula, then you can apply this formula. So you can apply this formula anywhere, but if it is changed from 0, 0 to other location, accordingly you have to change. So if you can do it in this way, then also it is fine. So here I have done in this way. The earlier way I told you that you can apply that distance formula, using that also you can find. So because the equation of a tangent to this line should be equal to of this format, same slope m, so it should be y equal to mx minus a plus minus of this. Because this and this should be same line, because this line has to be common tangent to this and this. So these two should be same line. For same line, the coefficient should be same. A1 by A2 should be equal to B1 by B2 is equal to C1 by C2. The A1 I have considered for 1, 1. This is mm, and this C1 and C2. You can take plus minus both. What will be your C here? Second one, here C is minus B, this one. Here C is not this one. 1 AM will also come, minus AM. So if you do this one, so this will be this. You can solve this one. You can take square from both sides. You will get the things are cancelled. Finally you will get this of this fashion. The way I told you, I told you to calculate this one. This will also give you. Let me write it b. If I take square both sides, then it will be, so you can write it ma plus b under root 1 plus m square is equal to plus minus b under root 1 plus m square. So if I take plus, then a is already 0. Because if I take, then that is cancelled, then m is equal to 0, a cannot be 0. So this cannot be, but they are asking you positive values of m. So m cannot be 0, because they are asking you positive values of m. So m is 0 is neither positive nor negative, so you don't take this value. So another value, for that you take the minus 1. So if you take the minus 1, then this plus b under root 1 plus m square is equal to minus b under root 1 plus m square. Then you take minus will be getting cancelled, so b under root 1 plus m square. So if you take square, then the same thing will be coming here, a square m square, you will find same thing, 4b square 1 plus m square. So ultimately you will get same thing. You see, a square by 4b square is equal to 1 plus m square by m square. So you will get the same thing here. Ultimately you will get the same answer. So you can go both way. So to use this formula, if you want to use this formula, the original formula that you have learned for condition of tangency, you need to do this modification in place of x and y. Or you can use normal theorem, that is, from the center the distance should be equal to radius. That is general, that is the standard for every cases. Now if you see this one, the radius of the circle having center this, which is one chord, is the diameter of the circle, this one. One chord becomes the diameter of another circle. So this is the chord which becomes diameter of the circle. Then the radius of circle having center. What is the radius of this circle? This one they are asking. So you know this point, this is the center of this circle, because this is the another chord is the diameter of this circle. This circle equation is also given, so you know this point, so you can find this distance, and this is because this is the diameter of this one, so this will be the radius. So once you know this, then you can find easily this. So the radius, so center of this one, from here you can see it is 1 3, this point is 1 3, so you know 2 1, so the distance BC is BC is the radius of this one, so that is calculated 2g square plus f square minus c, and AB is the distance between these 2 points. Once you know this, then you can find this, because it is the diameter of this one, that's why you can have done it in this way. So the length of AC is 3. If you like the video, then press the like button and please give your valuable comments in the comment section.